And we're live. Yo, yo, yo. And welcome back to another Bindplane community call. This time we're with you in February here with Ian and myself, Adnan from the Bindplane team. As always, I'm here and I'm your host. I do all things developer relations here. And today I have a very exciting guest. I have Ian from our engineering team. He's going to jump in and show you some really cool new product updates we've done. But more about that in a second. I'm not going to do any spoilers yet. I'm going to let Ian do all the cool stuff there. Yeah, let me hand over the mic. Ian, say hello.
Hi, my name's Ian. I'm a software engineer at Bindplane. I've been here close to 3 years now and enjoying working with OTel and developing a fantastic product for everyone to use.
Sweet. Truly is fantastic, or fantastical, how I like saying it. But cool. Yeah, as every community call we do every month, it's the standard. First, show you the agenda. We're going to jump through 4 quick topics in the roughly 30 minutes or so, maybe even less if we're lucky. We'll explain the Bindplane architecture. We'll go through some hot topics, of course, do some product updates, talk about new integrations, and of course, some really exciting demos as well. Of course, there's always a Q&A at the end, or you can just drop questions in the chat and we can get to those on demand or whilst we're talking as well. So let's just jump through the what is Bindplane section for all of our new community members that haven't been to one of these community calls before. And for everybody else, it's just a refresher. But yeah, Bindplane, it's an OpenTelemetry native telemetry pipeline, which basically means we make it super easy to collect, process, and export telemetry from any source to any destination. Doesn't really matter where you're running, what you're running, where you're collecting telemetry from, where you're sending it. We also enable super easy, high availability enterprise scale collector management. That's just a fancy way of saying we're a control plane that lets you run 1 million or more collectors in high availability, super easy without going nuts. And then, of course, that all boils down to cost reduction at the end of the day, where because you get visual routing, processing, you can configure all of this visually without having to look at YAML. Is just so much simpler and so much easier to do. You can expect, we have customers getting up to 50% cost reduction just because they can build processors so much easier. Now, from an architecture point of view, what's important to know is that Bindplane manages and configures all of your collectors via the op-amp protocol. So Bindplane is just a control plane. We're not required for any telemetry flow. All of your data is your data. It goes through your pipelines in your collectors. You can, of course, use the B.dot collector, which is the Bindplane distribution that we manage and we build. It's forked from the upstream collector, the collector contrib. So it's basically a fork that the community maintains as well. You can also just build your own collector with the op-amp extensions you need built in. We also support that. And then, of course, we make it super easy to run these collectors as either agents or gateways. We have setup scripts for everything. And you can, of course, choose whether you want to run it in the cloud or use a self-hosted instance of Bindplane. It's 100% vendor agnostic. You don't really have to think about that at all. From a network diagram, just so you know how all of this works, essentially the middle part is your network. It's literally where you run your collectors, very close to your workloads. How this works is that all of these collectors in the middle, via this dashed line to the left, communicate with Bindplane via this op-amp protocol. What that means is that it's essentially a WebSocket connection that opens up from the inside out. It's using these ports you can see here. It's via 443 on if you're using TLS, and it just stays open. All of the communication, the monitoring of the collectors, and pushing down configs remotely all happens via this WebSocket. So it's really convenient for security because you only open up a port from the inside out. You don't have to open up outbound ports because of it being a WebSocket connection. And I think that's really cool to know. And obviously for implementation for you guys, obviously pretty important to know. Now, from the collector point of view, you can obviously use the Bindplane collector. It's all pre-built and set for you to start using right away. You can also use custom collectors that you build yourself as long as you have the required modules to enable op-amp. We have this bring your own collector feature as well that you can basically pull in and have Bindplane manager existing collectors as well. Yeah, that's it for the network diagram. Now we're getting to the exciting stuff for this month. A massive hot topic, really exciting to share with you, is that Bindplane is officially ISO 27K certified. And that's not just the basic 27001. We also got the 27017 and the 27018. Tony from our team did a massive job setting all of this up. We're super proud of everybody that was part of this, and for you as community members and customers as well. It's a massive thing to know that we are officially ISO certified. We wrote a really cool blog post about this. I'm gonna actually show you that blog. And by we, I mean Tony. Tony absolutely killed it with this blog post. He literally dives into details on what we did, how we did it, how we're essentially focusing primarily on open source tooling in the CNCF. So yeah, it was such a cool thing and a very big effort from the team. Definitely something worth checking out. But yeah, I would say equally as exciting, kind of up there, is what Ian will talk about regarding the new upgraded persistent queues.
Yeah, so on top of our legacy persistent queue, which was used under the hood, which was the Bolt persistent queue, we didn't expose that as being explicitly the Bolt persistent queue in the past, but now we feel comfortable doing so because we've got two brand new options added on top of that one that you can use as a storage backend for your persistent queuing needs. Pebble and Badger are the two new backends we've added. They're both databases written in Go, and both of them offer some nice upgrade advantages over the legacy Bolt queue. But the reason why we're keeping the Bolt queue around as an option is because obviously a lot of customers are already using the Bolt queue, so we don't want to remove that as their option if it's working just fine for them. But for customers who are experiencing any sort of issues with the Bolt queue, we're looking forward to offering these two new exciting options and allowing them to pick something more tailored to their needs. And now I'm going to give a brief demo of these new options. So basically what I've done here is I've got sort of a gateway config implemented. So I've got 4 agents running. You've got one sending with a Badger persistent queue, one sending with a Bolt persistent queue, and one sending with a Pebble persistent queue. So all 3 of these, if we look at the underlying configuration, are receiving TCP logs and then just sending it out as OTLP. We've also got some metrics collection, which will be used to show off the differences in queue performance. So the other queues, the other configurations are really very similar. You've got TCP logs to OTLP with a Bolt persistent queue. And then finally, if we look at the last one, you've got TCP logs with a Pebble persistent queue. And all 3 of these agents are sending to the agent, a 4th agent, which is designed to basically just take all the data that those 3 agents are sending and basically just get rid of it for the purposes of this demo. But you notice that currently this source is paused, meaning that over the last half hour or so, as I've set up this demo, all that data from the first 3 agents has been getting steadily backed up in the persistent queue because it can't make it to the final destination. If we go ahead and look at a graph showing that off, we can see that, yes, over the last hour or so, the size of the persistent queue has been steadily climbing upwards. Now there's about around 10,000 messages in that persistent queue hanging out. And so what we're going to do for the purposes of this demo is we're going to take that queue drainer. We're going to unpause the destination. So this basically will result in, If we go ahead and look, we can see that previously this agent was running a config that did absolutely nothing. And now this has added all sorts of new pipelines. Well, one new pipeline specifically, and that pipeline goes from the OpenTelemetry source and sends it, basically just gets rid of that data. So if we roll this out to our agent, it'll happen nice and fast. And now all that data that was backed up in the queue for all three of those agents that we're sending to this one is going to start steadily draining as now that the source is live on the receiving agent's side. So if we refresh this again, this might take a little minute.
So whilst this is this loading, what did you see like in all of the tests you ran, in the benchmarks you ran? What was roughly the idea of which persistent queue you should use for what type of setup? I think that might be an interesting thing for the community to know.
Sure, absolutely. So a super broad summary, and again, we've actually got a great document on our document website indicating exactly what the use case is for each of these things. So if you're just running a single collector or a collector at the edge of your gateway graph, then you should probably use Pebble. Pebble is really, really low impact on the CPU usage, as we can see. And then additionally, it offers great performance on a single, for a single agent. Additionally, it while Badger is higher performing in certain cases, especially high throughput cases, its resource requirements are generally significantly more intensive than Pebble. So if you're working with a really high scale gateway, you might want to ramp that particular gateway node up and then use Badger just to handle all of the telemetry that's coming your way. But for anything on the edge of the graph, individual collectors, Pebble is a great solution. The one other thing to advocate in terms of Bolt is that if you're working with an existing network of agents and Bolt has been working fine for you, you haven't noticed any problems, we would suggest just staying on Bolt. There's no need to change what isn't broken. With that being said, in the past, we've seen certain issues with file corruption coming from Bolt, at which point there's really no way to recover from that, which is part of the reason why we've added these two new options that are much more resilient. So if you encounter any sort of file corruption resulting in, obviously, the loss of valuable telemetry data, that's the point at which we would suggest upgrading to Pebble or Badger, just because you obviously don't want to be losing telemetry data due to persistent queuing if your destination ever experiences an outage or something like that. So this is a great document to refer back to. It's got a fantastic summary of all three of our persistent queuing storage options with a quick decision guide down below. And then additionally, if you're ever looking to switch queues, we've got a great page for describing exactly how to switch queues without ever having to worry about losing data. So essentially what you do is you'll set up two pipelines in parallel. One will go from your existing data to your new queue destination, and one will go from a source that doesn't generate any data to your old queue destination, and that will drain the existing queue while ensuring that any new data gets sent to the same destination as before. So hopefully we can start to experience this. We can see that if we get really granular here as it drained, we can see that Badger and Pebble drained significantly more quickly. It started draining significantly faster. Let's actually drop this back 10 minutes. But obviously, while doing that, Badger's memory usage spiked significantly. And Bolt is, as we can see, actually the least performant in terms of I/O. So Yeah, I think that's a great summary. Any questions? Or I guess we don't have questions. This isn't a presentation, so.
Yeah, we can probably, hopefully, have some at the end. But yeah, it's a very, very nice run through of the new storage extensions and how our users can start using them and actually get a lot of benefit from moving to either Badger or dude, I keep forgetting the last one, Pebble. Damn. Well, I wasn't listening good enough. Yeah,
Hopefully our
awesome.
viewers are listening better.
Sweet. Yeah, let's jump back into the rest of the product updates we have for today. So the storage extensions were a massive undertaking for both Ian and Keith from our team. Amazing work on that. But we also have a couple of cool new integrations to talk about that we've released. So we have 2 new destinations and 2 new sources. Specifically, we have a native integration with StatSig now. StatSig is a telemetry backend vendor specified in product metrics. So it's really, really cool. We have a native destination for them. We have a new native file destination, so you can write to a file. And you also have we also have a new generic REST API source and a source for Prometheus remote write. So what that specifically looks like, I've just created a sample config here with some auto-generated or some generated logs and going into StatSig. I've also pinged the open GitHub API with our new generic REST API source, and I've sent some GitHub responses into a local log file. Now, it's probably saved and doesn't look. I'll just show you the log file, doesn't matter. But what's cool with StatSig is that now you can jump into their metrics explorer or logs explorer, and you can browse and you can see all of the telemetry you have going into StatSig right here. What's also cool is that this Prometheus remote write now supports. So we have the regular, I'm going to call it regular Prometheus source that does basically polling. The remote write is like just a server. You send all of your Prometheus metrics directly to it, and those get funneled into whatever backend you want. In this case, I'm just using StatSig, just like in the example above. Cool. Those are some really, really cool new integrations you can check out. And of course, I think the really, really cool update we have as well are about blueprints. So specifically, Chelsea, Laura, and Caleb from our team they've been mercilessly pushing out new blueprints for a bunch of new cool processors, and specifically for security, but also for Kubernetes, for ClickHouse, because we recently integrated, we did a partnership with ClickHouse. So we have, I think it's 5 or so. I think there's 5 new ClickHouse blueprints, a few new for Kubernetes, a bunch of new ones for security, including Okta, FortiGate, the MITRE attack framework. It's just a bunch of cool new stuff for you to try out. If you want to do that, best way to do that, just jump into the blueprints and add them to your library and just go nuts, try them out, see if they work for you. Hopefully they're going to make your life a lot easier with all of these pre-built processors. And they're really, really cool. Definitely have a look at that. And then for community updates, we can start wrapping this up slowly. We were at OTel Unplugged in Brussels. It was the day after FOSDEM. So FOSDEM is a huge free open source conference that happens in Brussels every year. We did a OTel Unplugged with the community the day after, which was essentially an unconference. So we got together with the community, a lot of maintainers and contributors to the project. We sat down, figured out where we want the project to head, how we want to help implement new features, build out stability and whatnot. So if you do want to check out the vibe from the conference, if you want to hear what some of the contributors wanted to talk about, and specifically the interviews, feel free to check it out. yeah, we had a lot of fun, and hopefully we're going to do it again next year. Sweet. Let's take a second for Q&A. We are exactly at the 20-minute mark, sweet spot, so we can take a break and check out the questions. So we do seem to have one from YouTube. So this is probably an interesting one for you, Ian. How can we calculate the effective persistent queue size in terms of gigabytes of local retention via the UI parameters?
Sure. So the metric I exposed in my dashboard was the queue size in terms of, logs, but there's a separate metric. Maybe I can pull that up quickly. There's a separate metric for calculating the queue size in terms of space on disk, essentially. So if you want to record that, you basically just, again, set up a metrics pipeline, sending metrics to whatever your chosen destination is, and then you will just pick that metric instead of the one that I chose to use for queue size, if that makes sense. I can go find that maybe shortly.
Yeah, we can obviously also follow up in the community Slack. We can drop a message in the community Slack and reconnect there. But yeah, this is a really, really good question. Cool. We could also update the documentation with a note to explain how we did the calculation. So you want me to switch over to your screen share?
No, if I find it.
It's all good. It doesn't matter. We don't have to do that right now. But yeah, we'll follow up in the community Slack, and we can drop a note there. And yeah, I think doing a note in the docs does make sense, just to help you out to figure that out easier. Wow, cool. Just a quick recap. What you can remember from today. We have a new ISO 27K certification, brand new persistent queue storage options, a bunch of new cool blueprints to try out. We have statzig as a destination, a file destination, and then we have 2 new sources for Prometheus and for a generic REST API. Yeah, that's pretty much it. We got under 30 minutes, and yeah, we want to be respectful of your time, give you back a couple of minutes today, and yeah, follow up again in March. See you next month. Thank you so much, Ian, for joining for the demo.
Thank you for having me.
Cheers. See you guys.